Hey, welcome to another coding session. This time we're going to do some more quality of life improvements for our compiler. There's a few things that I just feel like are getting a bit out of hand. For one thing that I do not like is if I change this to an assignment. So remember, this is the colon means that we're declaring a variable. So if we try to assign x before it's been declared, and then I try to compile that, it just says undeclared identifier. It's not telling me where it is or what the identifier was, or it's not giving me any information except that there's an undeclared identifier, which is super vague. So let's leave that here. So I want to, while we're tokenizing, I want to add to our tokens the line and column number so that as we progress through further parts of the compiler into the parsing and the generation, we can use that information to give better error messages. Then I also want to create a kind of a token stream, I guess I'll call it, which is just going to reference, it's just going to have our array of tokens, but then it's also going to have like a pointer, I guess, or an index of the current token that we're looking at. And it's just going to have a couple of functions like peek to look at the next one without incrementing the index. Actually, we'll probably have peek with an optional offset, so you could look further in the future as well if you want. Then we'll have a next, which will grab the next token and increment the index. And we'll also have a variation of next where you can specify a set of token types that it needs to be. And if it's not one of those, then it'll just throw an error and crash. We're still going to do our throw an error and crash business, but at least having it like this just means that we can just say, hey, get me the next token and I want it to be one of these. And we know that if we get a token back and the program hasn't crashed, that it was a valid token. I think that's mainly it. I think those two things, I think that second part, that stream, is going to make the parser a lot more concise. Right now, I feel like the parser is our weak point. It's a bit of a mess. It's a bit of a mess. So let's go into our tokenizer. So each token has a type, a value, now a line number, which will just make an int, and a column number. Column number. Great. And then when we're tokenizing, we're going to create a line and token number. Actually, maybe, you can do this. Can't you? Maybe I'm wrong. Maybe you cannot do that. Okay, we'll just do that. So we keep track of those. And so whenever we are going through here, at the moment, I'm just going to say, after we've processed a token, that the column number is incremented by the amount of tokens, the amount of characters that were used for that token. So for these single character tokens, it's very easy. And we're going to say line number and column number. Is it going to let me do that since they actually called that? Looks like it's not giving me an error. So that's like that. Our line number, in here we were doing nothing, but now we're going to if it was white space, but now we're going to say, look, if the white space is the new line character, then the line number needs to be incremented. And the column number needs to go back to 1. Actually, we start at 1, right? For line numbers, column numbers will start at 1. Okay. Cool. Cool, cool, cool. Actually, just for a better consistency, in these cases, they are responsible for updating the index. And in these other cases, I haven't made them responsible. And there's also that index plus 1 at the top. So I think it's going to be tidier to say, index equals end index. And in here, we're just going to say index plus equals 1. I feel like maybe that's more consistent. So all of the cases, they're always responsible for incrementing the index. So this guy is also responsible for it. And we can take that away. Yeah, maybe we can have some convenient stuff. Once our tokenizer gets a bit bigger, maybe we can improve some of the structure here. But mostly we're just interested in recording this line and column number right now. So yeah, so column number is incremented by 1, equals also is the same. And then we get in here, and we also want to, just add this stuff. So it's the line and column number at the start of the token that we're recording for these multi-character tokens. And then, and we know there's no new lines. New lines are never part of tokens. It's just white space. Unless it's a string, literal, with a new line in it. But we don't support that. Let's not think about that right now. We don't do string handling yet. String handling is scary. So we're going to plus equals, what is it, end index minus start index. So that's the length of the string, right? The length of the token, pretty sure. So we just do that for both of these. Like so. That was relatively painless, I think. And we can probably use that. I'm still going to leave that error message because I kind of like it. But I'm going to say we're going to print f line %i column %i, and we'll put the line number and column number in there. So we already have a better error message there, and then unrecognized token, unrecognized, invalid, unrecognized is fine. So then, I think invalid token is better. So we could test that actually. Like if we say x equals negative something, it says negative what though? At line 1, column 3. Awesome. And if we want to test, like further down in the file, line 11, you can see line 11, column 3. So 1, 2, 3. It's not column 3, is it? It's not column 3. It's like column 5, I guess. So the column number is wrong. And where is it going wrong? Because if we encounter white space that is not a new line, we want to increment the column number. Line 11, column 6. 1, 2, 3, 4, 5, 6. I feel like it's 5, column 5. So why would it be saying 6? Well, let's reason this through. We start at column number 1. Maybe we should be starting at column number 0, actually. No, we start at column number 1, so this is column number 1. 2, 3, 4, 5. So we're starting at 1. We come through, la-di-da-di-da-di-da, we find an identifier that has 1 character. Let's have a look what happens. Was X, so we've found X. So end index, start index, so we've got 1, so it should plus equal 1. So then we go to column 2. Then we find a space. So we come in here. It's not a new line. Oh. If it is a new line, we don't want to increment that column number, right? Yeah, so it was setting the column, it was resetting the column number to 1, and then it was doing an increment as well when there was a new line. Okay. I kind of accidentally found that bug, I think. Figured that bug out. So line 11, column 5. Perfect. All right, I'm already way happier about that. An invalid token, that'd be if we find some character that doesn't make any sense at all, like a $sign. Invalid token that's not right. Print F line. And I think we should actually print out the token. That would probably be helpful. Invalid token. But we don't know, we can't really say what the token is, because to print out the token, you need to know how long is the token. And if it's just, all we know is that we've encountered something that doesn't look like a token, we don't know how long it is. So I think at this point, we just have to leave it like this. But that's already way cooler. That's nice. Okay, so now now I'm going to create a token stream. Which is a struct, and it has tokens in it. Maybe it can just be a slice of tokens. This is our first time using a slice. So we should be able to take this dynamic array and make a slice from it. So that means that we're not copying the dynamic array. This is just a view into it. And I feel like this is also kind of another thing that's nice about it is it doesn't have to come from a dynamic array. It could come from a fixed size array, or it could be whatever. So it doesn't force your token stream to be backed by a dynamic array. And then we're going to say, I don't know, current index. That'll do. There we go. So we've got a token stream. And we're going to say next token. And let's see if I can remember how to do this. You can do function overloading in Odin, and I believe it is like I can do next token any and next token of type, and they're both procedures. And then I think I could just go like, this guy is one of them. I can't remember the syntax for this. So I did use it somewhere else. Let's go to Odin. Let's go to explicit procedure overloading. Here we go. So it's you go proc, and then in curly braces you put your two variants. So was that it? The name of it, and I think, what would be the problem with that? Would the problem be that this needs to be declared after them? Oh, it has the same type. Yeah, because these two, I mean, the whole point of overloading is they need to take different parameters. And I'm not giving them different parameters. So this one takes types, which again is a slice of AST nodes, AST node types. There, now everybody's happy. So this, and they both need to take in a token stream pointer. And yeah, both need to take in a token stream pointer. And so the next token any is just going to say, like, you know, if current index is greater than or equal to the length of stream.tokens, well, then we've got to the end. Oh, look at that. Unexpected end of file. On a stream.current index. So I'm not sure how to give that more context. We could get the last token in the stream and get the line. Yeah, let's do that. After token at, it's a little bit weird, but at least it's something. Column %i. But what about the case where there are no tokens in the file? If we just have an empty file, yeah, that's a bit of a strange edge case, isn't it? And let's not handle it right now. So that edge case would crash as it is. But that, I'm going to say that's fine. Streams.token, so length of stream.tokens -1. So that's the last token. We'll say last token dot line number, last token dot column number. Yeah. So in the edge case that that there are no tokens in the file, this is just going to crash. We're not even going to get a nice error message. It's going to crash because this is going to be out of bounds. Arrays and slices and things do have bounds checking in Odin. I like that. So now if we want a next token of a particular type, we're going to say for, yeah, I don't know a better way to do this. So we're going to say for type in types, and we're just going to have a Boolean that we update. So if type equal, so we get the next token, right? So we're doing our bounds checking here. Maybe we'll extract that and we'll say has next token. Yeah, has next token. We'll say assert has next token because it crashes, like it throws an error and crashes the program if it doesn't. So it's like an assertion. It's not just like returning a Boolean, which I would expect from has next token. Okay. And I think this one actually does not need to be a pointer because we're not modifying stream. And I think that is I think it's good to stick to that convention. I think that's a kind of a convention in Odin. So we know there's a token. Then we know there's another token. So stream.tokens stream.current. Actually, I guess maybe it makes, because we're calling this next, right? Let's call it next index. I think that makes more sense. There's next index. So if it equals the type of the next index, then we say type found is true. We're not redeclaring. And we break. And this is not happy. Did you mean a dereference? I did mean a dereference. I just get a bit confused about them sometimes, how to do them. AST node type and token type. This should be a token type. There we go. Okay, so then we say, look, if not type found, then we're going to throw an error. We're going to say invalid token at, well, let's just go. Assert has next token. No, I think this is, okay. I think next token any just, it should verify it and then it should return. It should return the next token, right? increments the index and then returns. So that needs to be a token. There we go. Yeah, and then, so I'm just saying, like, you know, get me the next token. And if the type of the next token is all good, great. Then return the next token. Not sure why that's going green. I thought green was when you declare something. That's where I'd noticed it before. But so yeah, we do the next token that would allow any. And then afterwards, we also check like, hey, is this the right kind of token? If not, we say invalid token here. And we say expected. I'd kind of like to print, this needs to be printf line. So does this. I kind of expected, or I would like to say, you know, expected and then put in the types. And then found. And put in the next token type. But I don't know. Let's try putting S, like, I don't know what formatting to put. I think that's probably going to be wrong. But so that's, those two functions will allow us to get another token. Oh, we don't need this assert anymore. So if we call next token, we can optionally supply the list of token types that are valid, and this will get us another token. And I also want to go peak token. And this, and is there a, can I do that? Okay, I just want a default argument. Here, get back a token. We also need to pass in the token stream, which does not need to be a pointer here. But we do also need to, okay, so maybe we can even move this up here. Or with peak. No, I think peak also has to return something. I think that's easier that way. So, but it returns something without incrementing the next index. So then this guy will go, next token is peak token with the stream. And he also increments. So the difference with next token is that he increments the pointer, the next index, whereas peak does not. And you can also peek further ahead like that. Okay, so I think those are going to work. We can peek a token, we can get the next token. Those are the main things I was thinking of. So if we go over to our parser, let's go to the top of our parser. So when we take our tokens into our parser, what I actually want as a token stream. We're going to say a pointer to a token stream. And we're going to say, not while, can't do while. So it's kind of like, as long as there is more tokens. So I'm just going to say, maybe I should call that stream. What do I call it over here in these functions? Yeah, I call it stream. Let's just call it stream. So if stream dot next index is less than the length, next index is less than the length means there's more tokens. Yeah. While there's more tokens, we pass in our stream. We don't need to pass an index in anymore. And I think we don't need to get a token count back anymore. We don't need to keep track of this. So we probably could just do this. Let's see what happens. So here we can take away our token count, just pass our stream in. Yeah, so that's happy now. So now we want to check the first token, the next token in the stream. So we're going to say peak token. Dot type. For simplicity, I'm just going to make that a pointer as well. I think it's just easier if it's always the same type. So we don't need to worry about dereferencing the pointer. Okay, parse scope is going to take that in. It's going to return a node. Don't have to keep track of that. And node becomes that. So I mean, really we just need that. See, this is looking much better, right? Much better. Before we handle these other cases, let's try parse scope. So it's also going to be basically this. Opening squiggly bracket. Great. So this is where I want to go. Next token in the stream. Opening squiggly bracket. Missing type in compound literal. So do I need to do token type? I'm sure I tested this before, but not with an enum. Types, it's a slice of token type. Missing type in compound literal. Odin, missing type in compound literal. Let's put that in quotes. When calling procedure group. Okay, because yeah, I am calling procedure group. And it's a set he's using, and he's using a literal. Missing type in compound literal, okay, because he's explicitly doing a. Okay, because he's saying set. So we can just do that. Yeah, I think it doesn't look the nicest, but we're just explicitly saying this is a token type slice. I guess that's something to do with the resolution of the overloaded functions. We don't really need to do that overloading, but let's keep it anyway. So before, see, this was the open squiggly bracket, and we're advancing the token, which is now handled by next token, and it's verifying that it's an open squiggly bracket. So that's nice. And now we do some statements. And we're saying while we haven't reached the end of the file. So it's similar to this loop up the top. While we haven't reached the end of the file. And if we find the closing squiggly bracket, then we're done. So we don't want to do this one where we force it to be the squiggly bracket, and we don't even want to consume it because if it's not the squiggly bracket, we want it still to be the next token in the stream so that when we do our statement, it uses that token. So this is a peak. So peak token in the stream, and if the type of it is squiggly bracket, then we want to consume it. And I guess, I mean, it's not really necessary at this point to verify that it's a squiggly bracket, but it's kind of nice and explicit, that code, right? And now we're basically, parsing the statement. We don't need to worry about all this token count business. And we need to pass the stream in. Beautiful. Scope never ends. That's still valid. Okay. So let's move on to our next case up here in the statement parsing. So if we start with an identifier, we don't need to do this kind of checking anymore because we can do peak token with an offset of 1. We call that index. I think offset is better. Index. That was not a very good parameter name. So with an offset of 1, and we should find that that's one of these. Again, this whole token count business, we don't care about token counts. Actually, this gets reduced to one line. Just passing the stream in. And that's the assignment and the exit. And I think we can just go like this. Beautiful. And here I think we can say like invalid token at line column print if line, and it's this token here. We'll just peek it to get the stuff. That's good enough. And here it's the next one. So maybe we'll go like this. And same here. But this time we're going to get with an offset of 1. And for a bit more context, we'll say failed to parse statement. Okay, see, this error message is so much nicer. And also the code, look how concise this is now. So much nicer. Okay. And these are errors because I haven't fixed up the corresponding functions yet. They should have a function signature like this. Let's do this. Basically, all the functions in this file should have that signature now. So let's just go through and correct them all. That's all of them. Okay, parsing a declaration statement. First, we're verifying that we have enough tokens, not needed anymore. Now we're making a node from the first token, which needs to be an identifier. So we get the next token in the stream, and we verify that it is an identifier. My reasoning behind having a slice here was because I thought there would be like cases where we have multiple valid identifiers, which I guess is the case, with these switches. That's right, I was thinking that that could take care of this error handling. If we did it at the top of the switch, let's just leave it for now. Okay, token counts, we don't care. Left-hand side node, do we use that anywhere else? No. But I kind of like the explicitness of saying this is the left-hand side node. So then when we go to generation, we can sort of cross-reference with the parser and go, yeah, okay, the first node in the statement is the left-hand side node. I like that bit of information. Now we've got the colon and the equals, and we have the verification stuff here. But we're just going to go colon and equals. So we don't need any of that. So we're just verifying the next two tokens. And then we do our right hand side token, which is just parsing the term. How much nicer is that? How much nicer is that to read? I'm blown away at how much better that is. We create a left-hand side token, which is type identifier using this token, which we verify as an identifier. Then we just verify that the next two tokens are colon and equals. Then we parse the term. We can just, we were going to do, like we said here, we'll keep it so we have the name right-hand side. So nice. Don't need this. Don't need this. This is the same as before. Like that. A little bit verbose, but don't need this. So this is we're verifying it equals, just like here. So that becomes that. Don't need this. Parse term just needs to take in the stream. Voila. Very nice. Very, very nice. Don't need this. Don't need this is like the motto of this episode. Don't need this. Okay. So an exit statement starts with an identifier. And we're not even verifying, are we, that it parse exit statement. We're not even verifying that it says exit. It could be any identifier and it would work. even if it's an identifier that's already been declared or something, like it could be X, one of the variables from before, and it would just work. That's so crazy. So we could add some checks here. This opening bracket we're just taking care of. So we could go if exit token dot value does not equal exit, that doesn't say exit, and something along the lines of, failed to parse exit statement, and we'll just say exit token. Okay. I guess this will eventually become a more generic like function call. Okay, right, so this start index +2 business is just not needed anymore. Because we're using this next token thing to advance us through the stream, we're just always in the right position, and we don't need to maintain this, or at least not externally to the stream. We don't need to maintain it, which is really nice. So this is the closing bracket, like so. That's right, we can get rid of this. So creating an exit statement. First we get an identifier, we verify that it's actually exit, then an opening bracket, then we parse the term, which is the parameter, then we get a closing bracket. Perfect. And when we're parsing the term, while we're at it, something I'm going to do is I'm going to say this child node business is just stupid. I don't like it. So I'm going to get rid of it. Maybe later it will make sense to bring it back. Okay. So here we can get rid of this and this, because we only have one node now. So I think basically it seems to be the pattern, that I do this first and then we start taking care of tokens. So, okay, so this is interesting. This is where we can say, we can actually use this. It's got to be identifier and integer literal. I'm going to just say that's our token. And we can assign token dot value. No, we can't, because they're different enums. So you can't do that. So we still need to do this business, which feels a bit weird. We don't need this default case anymore because it can be a good sanity check. In case this and this do not match, it'd be good to have something here. And again, we'll put something like this. Failed to parse term, invalid token. Why am I not putting the token in these? Yeah. Let's do something like that. Maybe because a lot of them, no, they all have values. Tokens all have values. AST nodes do not all have values, but tokens do. Valid token, invalid token, token dot value, and token dot value. Oh, exit token. All right. Wow. I think that's much nicer, and it's going to result in, should be exactly the same AST tree. AST tree that's redundant T. So that should work, he says confidently. Okay. Cannot assign value tokens of type dynamic token to token stream in a procedure argument. And I think that's because we have not looked at the, that's Bangalang. We have not looked at the main file yet. And it's expecting that, so we go token stream. I'm actually not sure if we even need to do that. So I think to make a slice of the whole thing, type token stream procedure argument, because we need a pointer. Pointer to stream. So what's the issue here? Too few values and struct little. Expected 2 got 1. I think that's because you have to name them if you're not going to supply all of them. Okay, now what's wrong here? Oh yeah, address of. Okay, let's try that. Invalid token at line 12, column 1. That's because we did this. Index out of range during generation. And this is because we removed that child node business, so we don't need to do this dot children 0. So I think yes, truffle. I don't know if you can hear the cat. I think it's everywhere we have this. So if we go to the declaration statement, yes, truffle. Good kitty. The right-hand side node is a term. So that means that this right-hand side did used to have this business, but it does not anymore. So we take all this out. Everywhere that's right-hand side dot children 0 in that function. That one's okay. And for assignment, also the right-hand side was a term. So right-hand side, we can take away this stuff in the assignment. So we are simplifying the generator just a teensy bit. And that one is okay. And in the exit statement, there is also a term, isn't there? Exit statement, the parameter node is a term. So the parameter node, we can take this away. Yeah, so that's where it's already come in handy that I give this a name, param node, and then I come over here and I also have param node. So I know that I'm talking about the same node. Okay, fingers crossed. Undeclared identifier. Undeclared identifier and like no information? Does that still happen? Okay, so the error messages in the generator have not been improved. Is undeclared identifier really, should that really be happening? Yes, up here. Because remember, we changed it to be an assignment instead of a declaration. Okay, so that's nice actually, because then we get to tidy this up. So let's start from the top. Go to open NASM file. That's just a general thing. Invalid statement. Invalid statement. But the nodes don't have the information. The nodes don't have the information. So I think we're going to need to pass. We're coming up on an hour, but I think we're nearly there. I think we just need to append this information to a node as well. And then whenever we create a node, this is going to be the tricky bit to find. Whenever we create a node, we need to give it the info. So I think I do it at the end, because at the end, oh no, I can't do it at the end, because at the end, the stream would have advanced and we go to the, because what I was thinking was we'll take the information from the first node, like in this case, the node is a statement. And I want to take the line and column information from the first token in the statement so that it points to the start of the statement. I feel like that's the most logical. So, node dot, actually this parse statement is just the, maybe it makes sense to put it here, because that's kind of like, you know, I'm just setting up the non-conditional information, I guess. Let's just go peak node stream dot line number. Is that not okay? Peak token. So I think that kind of thing just needs to be at the top of every function. We could probably make a convenience for that at some point. Like maybe a kind of a constructor or a factory or something that just sets up the node with this info. I mean, it's not going to be honest, it's not going to be much simpler than this. So maybe it's just not worth it. And the term, yeah, so we just added all the information. So now we can come in and we can say, in the generator, we can say invalid statement. Maybe we can take something like this, like failed to generate statement. I like that because then that's kind of telling us that it's in the generation stuff. And we say invalid node. Invalid node. And line one column, whatever. We kind of have to have the like expected and stuff, but I think this is kind of enough for now. Because we have spent quite a bit of time on this already. So undeclared identifier. Failed to generate declaration statement. Undeclared identifier %s. This one we put the right hand side node, because that's specifically what we're talking about. Invalid statement. So what is that really saying? It's saying that the right hand side node is not valid. So it's like Yeah, it's like that one. Oh God, I did too much scrolling and now I'm lost. Okay, here it is. Invalid column, and we're talking about the right-hand side node here. It's invalid. Yeah. Identifier already exists. Or like maybe a more fancy way to say is duplicate identifier. And we'll say duplicate identifier at this place. And we put in the string. I think we should, that's more consistent with the other error messages, I think, putting it in single quotes. So duplicate identifier, which is left-hand side node dot value, which also means that this information should point to the left-hand side node. Here's another undeclared identifier, so let's find that. Here we go. There's undeclared identifier. This is an assignment. We were talking about the right-hand side node. Yeah, great. Invalid. So it's going to be the same kind of error messages because this is like a very similar function. It's just that it's assignment. And I put assignment there, good. And duplicate identifier, do we have something equivalent here? Undeclared identifier. Yeah, that makes sense. Here's undeclared identifier. So this is left-hand side node. Yep. Anything more? Down here is invalid statement. This is exit statement. And that's because you didn't have an identifier or integer. Now, I didn't really think about this for other cases, but for this case, and like this case as well, really the parser should take care of this. The nodes should be correct at this point. But it is good to have this error here so that if, like, they should be correct, but if they happen not to be correct, it's good to get an error that is usable. So failed to generate exit statement, invalid node. The param node is an invalid node. Yeah, I guess anywhere where it says invalid node is kind of like it shouldn't happen. Okay, failed to generate assignment statement. Undeclared identifier X at line 0, column 0. Boom. That's absolutely right. I'm going to get rid of this printing of AST nodes. And let's have a peek at the assembly. Declare, declare, assign, starting a scope where we assign and we declare again. And lots of declaring and assigning because that's all we can do. And so y is 34, then y becomes 77. Then we assign y to z, and then we return with z. So we should get a return of 77. So it's working nicely, and it's giving us way better error messages. Like if I say F77, failed to generate assignment statement, undeclared identifier F77 at line 6, column 9. Yeah, because I guess F77, is an identifier, right? It should have been a variable that someone declared before, but they didn't. I was thinking that it would say like, this is the wrong kind of token, or um, like what is a token that we could put there if we put equals again? Oh yeah, that's right. I wanted to see how this printed out, and it's printing out. I'm pretty happy with how it's printing out. So invalid token at line 6, column 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Expected an identifier or an integer little, and we got equals. So these error messages are just so much better. It's a huge difference. I'm really happy with these. And also the parser is just like, oh, it was not very nice to work with before. But now look how like clean it is, It's like, okay, do we have more tokens? Let's parse some statements. Okay, let's have a look at the first token. Is it an open and squiggly? All right, let's parse the scope. Is it an identifier? Well, let's look at the second token to see what to do. Is it a colon? Let's do the declaration. Is it an equals? Let's do the assignment or the exit. And some error handling. Yeah, it's just so much more concise. Like this, it's so much clearer what's going on. And I'm blown away that we managed to get through this without too many errors. Again, there was a couple of things we had wrong, but yeah, fantastic. Okay, so I feel like we've recently done quite a lot of maintenance. This episode was maintenance. 2 episodes ago was also maintenance. But I feel like we're in a really good place now where we can really pile on the features. I mean, definitely in the parser, the generation is pretty good. We might be able to clean things up a little bit, but I think, it's not so bad. Well, I think we need to clean up this business. This manual allocate space on stack, because there is a push. I could just push, not push 8, but push whatever it is I want to push, and it would automatically do this. I don't need to, I don't need to do that. So it could reduce this whole function here into one line of assembly instead of, currently it's 3, it could be 1. I think it could be 1 line. Okay. Yeah, let me have a little bit of think about what we're going to do next. I think arithmetic would be cool. And then expanding on our scopes, let's get some functions would be a bit tricky, but we could have some functions going. We could have some if statements, some for statements, for loops, that kind of thing. Yeah, exciting. All right. That's all for today. Thanks for stopping by. Don't forget to like the video if you want me to continue the series. Yeah. Ciao for now.